This meeting is being recorded.
For problem 9 from chapter 11, we are asked to propose an efficient synthesis for each of these following transformations. So I will solve parts A and B with you here. And as always, we know that an efficient synthesis is generally one that involves the least amount of steps. So that will be our goal here. So let's take a look at our transformation in part A. So we have this alkyl halide, and then our product is an epoxide. So we have seen if we used retro synthetic analysis, we could think that this last step in our transformation could likely be that of an alkene to an epoxide. So that's what we see down here, this alkene intermediate product. And prior to that, we had an alkyne shown here. So that's the plan that we are going to use. That's the steps that we'll use here. So in this first step, we can use acetylide here, sodium acetylide. And we can lengthen our carbon chain by 2 atoms. So 1, 2, 3, 4. Now we have 1, 2, 3, 4, 5, 6. So we're getting a little closer to our product. And then how can we go from an alkyne to an alkene if we just want to stop after one equivalent of hydrogen? So H2 and Lindlar's catalyst could be used. So we would just do one addition using a poison catalyst, and then we end up with this alkene. And then we could use some peroxy acid here. So something like MCPBA could be used to accomplish this transformation from alkene to epoxide. So this would be 1 to 3 steps in this efficient synthesis. So let's look at part B here. And we have this dihalide here as our starting material. And then our product is a ketone, right? So we have to change our functional group, but the location remains the same. So we have specifically a methyl ketone. So we've seen methyl ketones prepared from alkynes in a previous chapter. So that's our plan here. So using that retrosynthetic analysis, we know that we can create that this methyl ketone from that alkyne. So let's see if we can bridge the gap to go between that dihalide and this alkyne. So we know that both vicinal or geminal dihalides can undergo 2 eliminations using excess sodium amide. And then we can use a water workup here to generate the alkyne shown as our intermediate. And then to convert this to the methyl ketone, we can use these following reagents. We could use mercuric sulfate, so HgSO4 in H2O, H2SO4 rather, in H2O.